Okay, again, I want to thank everybody for joining us for today's session. It's Astrix webinar, Developing Your Lab Informatics Roadmap Through Business Process Analysis. Next slide, please. So before we get into today's content, I want to give you kind of a brief overview of who Astrix is, so you have an understanding of why we're talking to folks about this content and who we are in the market if you haven't participated in any of our webinars to date. So first and foremost, we're an informatics professional services and staffing company that's dedicated to serving the scientific community. Some quick stats about who Astrix is and where we came from. We were established in 1995 and are privately held. We originated as the IT division of a company called APBI, which was a $300 million life science research organization. Today, we operate with 7 offices in the United States and beautiful Costa Rica, with our headquarters in Red Bank, New Jersey. We have about 800 employees total, and we target customers who are Fortune 1000 life science enterprise, chemical, CPG, government, research institutions, all with large and fast-growing IT that may have outsourced needs or compliance needs. The mission of Astrix is and always will be to deliver scalable, sustainable solutions for the scientific community. Next slide, please. So you're hearing from the professional services division of Astrix, and within this division, we provide a whole suite of services that span the complete life cycle of your scientific data systems. This includes everything from business process analysis and enterprise architecture. The gentleman who's going to give a presentation today leads that group for Astrix, and this is a type of service where we ensure that you are selecting the right technology, that your technology is being built, in a stack that's going to scale and get you where you need to go, if that's digitizing, moving to the cloud, etc. So right through laboratory technology selection service. Then there's the more traditional services of development and implementation. That's where we actually help you deploy, configure, customize, build analytics around your lab informatics. And then computer systems validation to make sure that it works within the context of the FDA regulatory guidance. And then finally, there's 360-degree laboratory system services. This is customized pay-as-you-go solutions for laboratory software and hardware. And then scientific and technical staffing services. So again, this spans the complete life cycle of scientific data systems. We help you evaluate, implement, and manage systems to enhance the collection and processing of scientific data. Now with that, I would like to introduce you to our speaker for today. So Quan is Managing Director of Strategic Services here at Astrix Technology Group. He's been involved in leading teams that have implemented numerous scientific informatics solutions that support research and development and biotech and pharma companies. With a very strong scientific background and life science industry expertise, he has the ability to collaborate with clients and identify opportunities to deliver solutions that provide value. Great ability to understand diverse scientific workflows and ever-changing, adaptable business processes. So we'll go ahead and you can certainly read his full bio at your leisure. But with that, I want to go ahead and introduce Quan and let him pick up the presentation from here and take you through the rest of it. Quan?
Thanks, Kevin, and thank you for joining us today during this time. So we really want to talk a little bit about kind of how business process analysis can support and kind of better inform your decision on technology and an informatics roadmap. So if we look at the scientific informatics landscape, it can be complicated and overwhelming with a mix of different solutions. Beyond the kind of list of TLAs for the different solutions that I'm showing here, the continuing lower cost of storage and increasing precision and improved analytical methods, more and more data is actually being captured every day. This can lead to lots of confusion. What information should I put where? Should I extend this solution beyond its capabilities to meet a need, or is there actually a better solution? How do I integrate all this stuff together so that I can actually maximize the use of my information and derive business value? Should I warehouse my data? If so, what data should get warehoused? What is my system of record? Do I have one system for master data, or are there different systems that all have to be integrated and managed carefully? How do I plan on supporting reporting, analytics, and business intelligence across this landscape? And who needs what, when, and where? A lot of these questions hinge on the various users of these systems and how these systems are being used to support your entire scientific process. But people often forget to look at when they actually look at technology. So to help better unravel the landscape and the large number of choices, many companies are looking to evaluate their technology, their people, and their processes as part of their digital transformation strategy. We've actually worked with many organizations that have acquired technology over time, or sometimes have been quick to acquire or make a purchasing decision because they needed a system, but they failed to look at their business process to better understand how this new system will support their entire scientific process. Instead, they end up focusing on a very narrowly focused feature set of something they need immediately. But really, what we really need to look at is, from digital transformation perspective, is to look at this golden triangle. So let's first take a look at technology. This includes the infrastructure, software solutions, and how it all works together. Technology itself will not be the solution, and the choices for technology should really be informed by your business processes. Next, taking a look at people. The key to understanding this is the people in your organization and the senior leadership's commitment to making the investment to digitize, the investment of time from key stakeholders, and the willingness to develop and implement an adoption plan that only not includes just the technology itself, but also improved business processes. So the last piece, which is really kind of maybe arguably the most important of it, is the actual process. Getting an assessment of your current business process, workflows, and individual steps, developing the current state with sufficient details to understand inputs, outputs, and dependencies, and then truly defining what that current as-is process is, making that the baseline for then using best practices and your organization's change agents to help define what the future, more optimized state will be. That's really where you want to spend the time, and then layer on the technology. Those process maps, inputs, outputs will really help inform your technology decision. Of course, there's always additional considerations from the IT organization and infrastructure preferences, such as what type of cloud environment, what's the integration framework and strategy, how is reporting, analytics, and business intelligence already being managed within the organization. All those obviously have to inform the technology choices as well, but the technology itself is really only as good as the processes that are being implemented around it. So let's take a look at what business process analysis is and what are its key objectives. Simply stated, it's really to capture the current states to get everyone on the same page, optimize a future state, and then use that information to inform your technology decisions. How do we go about accomplishing this? Well, to capture the current state, reviewing existing business processes, related documentation such as SOPs, work instructions, and then conducting key stakeholder interviews allows us to gather the information that gives us a holistic view of the entire business process. During this process, interactive whiteboard sessions, workshops, and discussions are had to really bring out the hidden challenges and opportunities. Always along the way, validating what has been captured to make sure that the scientists are in agreement and what's documented is actually correct. When going through this process, don't get stuck in the never-ending rabbit holes and focus on capturing, and really just focus on capturing the key focus areas to a good level of detail. Don't aim for perfection. That may take forever. What we want to do is aim for good enough to be able to have the right level of detail to inform our future decisions. Once everything's been documented, you want to incorporate best practices. So really designing that future state. And these best practices can come from within the organization, maybe a scientist who's completed a similar project at another organization. Or you can leverage industry experts and consultants to help bring a greater diversity of experience to the table. Make sure that you don't start this step, the designing of the future state, too early. Otherwise, you're trying to fix the process before you actually have it fully documented in the as-is state. As you're looking to design the future state, look for steps that seem redundant, create delays, or just unneeded steps. Really challenge those unneeded steps and figure out why they're in place. Not just because someone used to do it and that's the way we've always done it, but understand what that business rationale is. Once all the details are sorted, a new to-be state process map can be created. And now what we do is we begin to layer the technology, which is informed by the business process. This gives us the ability to have clear objective requirements to identify all the dependencies, both human and technology, in the new process. Begin to layer in different systems that could automate processes, capture information more robustly, eliminate manual and error-prone steps that handcuffs the organization. This is where you want to bring together your business process with software that can support those particular actions. Actual business process mapping can actually be traced back over a century ago when two engineers introduced business process flows and flowcharts in a presentation that they titled Process Charts, First Steps in Finding the Best Way to Do Work. Although I don't think there's necessarily one best way to do work, it nonetheless became something that was adopted by the American Society of Mechanical Engineers back in the 40s. And today, there are many tools on the market that help develop business processes. Tools such as IBM Blueworks, Visio, or other cloud-hosted solutions such as Lucidchart that enable the development of these process maps. However, regardless of the tools, the key tenets still hold true. Business process mapping is really a visual representation of your work process. This could be as simple as something as simple as how are samples received in my laboratory and documented during the receipt process? How do analysts perform assays or tests in the laboratory? How do they enter their results? How do they upload their results from instrumentation? How is data reviewed or released? Even some things such as, how's my inventory managed? The key is to create small enough bite-sized chunks of work and activities and then pull them all together into and keeping their relationships into a greater full end state process map. Business process analysis will need to make sure to capture all the inputs, outputs, the various decision points, whether they're human or automated. Can something be automated when you look at decision points? And then identify all the different dependencies. It's funny how sometimes when you start something such as a business process analysis, some person comes along and says, well, the output is this Excel spreadsheet that I actually email somebody. Well, there's a natural spot where technology can easily remove that step. This is how as-is mapping can really help identify areas for improvement. And once everyone is on the same page with the as-is state, it'll be much easier to move forward with creating the optimized future state. There are different types of business process diagrams that can be generated, and we'll talk about some of them in the future in a minute. But obviously, there are swim lane diagrams, just general flow charts, and then obviously state charts as well that allow us to decide when I actually transition from one status to another status, what has to happen? And all of these actually fit into how requirements will be made for your systems of choice, so that you can better understand, I don't need something that does X, Y, or Z, but what is the business process that I'm trying to manage or control by leveraging technology? Okay. So if you think about how business process mapping starts, it starts out with typically a high-level overview. And obviously what I'm showing here when I'm talking about how samples will get tested in a laboratory, for example, this is probably insufficient level of detail to be meaningful in order to kind of make technology choices and inform your technology decisions. So how do you actually get to that level of detail that is meaningful? First, when you talk to people, it starts out at a very high level, which is a good start, but doesn't really get down to that level of detail that gives you that meaningful information that allows you to make recommendations or really understand the challenges they may be facing, or even provide enough insight to be able to offer a better future state process. Each of these high-level processes, such as how samples arrive in the laboratory, how results get generated, need to be broken down into more discrete steps that then become actionable when making choices about technology. For example, consider things such as, what in my sample receipt process is important to me, and what differentiates my business over others? Who's involved in this process? What are the inputs and outputs? And when do I know I'm done? Whiteboard sessions, stakeholder interviews, workshops, these are all tools that are used to further refine the requirements down to the level of detail that allows for creation of a more detailed process flow that really gives us the ability to make meaningful recommendations and have meaningful insights into how do we actually optimize the business process. So let's take a look at a detailed business process map, such as the one shown here, that ensures kind of decision points are captured, dependencies are identified, and all the different states are captured in enough detail so that all the stakeholders have a good understanding of the process. Oftentimes, these will take days to create, and once documented, can serve as actually a living document to help improve the business process. The example shown here is a flow chart, which is a graphic illustration of the process that has about 130 steps. These can be combined across functional areas, which we're actually finding more and more important nowadays because of the nature of research and the number of cross-functional teams that have to be involved in the scientific process. When you actually get across those particular different cross-functional teams, those are then often depicted as swim lanes that allow for capturing the sub-process, the abilities of different teams, labs, or function areas within the overall process. That then clearly delineates all the different handoffs, all the different exchange points, and really allows you to identify areas whether you may have actual inefficiencies or wait times because of lack of technology, or simply because of a lack of a better understanding how the two teams have to operate together. But actually putting it onto paper and getting common agreement between the teams helps identify that potential bottleneck and allows people to move forward with deciding how to actually resolve and create a better future state. Once we've developed the business process map, there are a large number of benefits that can be gained. First, it obviously helps everyone make sure that they are on the same page and see the processes the same way. Once there's common agreement, it's much easier to develop a better future state. These business process flows can be summarized for management so they have an understanding of what organizational change and cross-functional dependencies exist in the entire process. You can readily use business process flows to identify inefficiencies, redundancies, as well as gaps in the business process that will need to be addressed. Once the business process is developed, you can establish metrics, scorecards, and KPIs that allow you to measure how much faster, how many more assays can be run, how many more samples can be processed, and be able to further optimize in the future. Establishing these KPIs and metrics allows you to quickly then turn around and identify what's my return on investment. Can I actually improve my process? Can I actually process more samples? Do I need more equipment? Is my bottleneck researchers? Is it actually equipment? Is it a specific type of technology? Can I remove redundancies by putting in integration so that I'm not double entering information that can easily be transferred from instrumentation directly into software solutions? And lastly, with everyone on the same page and steps that are taken to improve the overall process, the quality of science and the speed of discovery will improve. So if we look now at the 5 steps for getting to a better to-be state, once we've actually completed the first 3 steps of identifying the key business processes that we want to map, gathering the required information, and documenting the current state through those as-is process maps and really requirements, workshops, etc. The next step is to put in place better steps and better processes. When looking at the current state, you'll want to rethink the steps. Look for opportunities to reconfigure or resequence steps. I think of this as, do I have straight lines on my business process map, or are they just all over the place? What do we need to do with clients? What we need to do with clients is to look at their processes that appear to be redundant or have no real value or utility, and any unnecessary steps that cause delays or bottlenecks or simply vague. We challenge our clients to look at those steps and see if there's actually a better way to resequence those, reorder them, and identify better ways to remove those bottlenecks. When looking at process improvements, think about the unit of work and what that unit of work is. So in some areas, it may be how many assays that can be completed. In the other areas, it may be how quickly can samples be received and put into the freezer. In other cases, it may be how quickly can my product be released and a certificate of analysis be sent out along with my product. Or how many analyses can be reviewed, and put a measurement or a KPI on that particular step to see what gains you can make by making technology and process improvements, allowing you to say, if I remove this particular step, if we integrate instruments as opposed to having manual rekeying and double data entry, how do I then improve my throughput and improve the utilization of my resources within my organization? When going through this process, you want to leverage industry experts. And one that I've always liked in my career is to get a viewpoint from an adjacent industry or someone who solved a similar type of problem in another area of the business. Even though it might not be an exact, completely relevant match, there may be some ideas that you can take away from that and incorporate into your future state. I've worked in organizations where people from the finance industry have served as business analysts on certain projects, or even the aviation industry. And they've brought their own view on how processes can be optimized, what they did to solve a particular need in their past employments. And then taking some of that thought and figuring out, how do I mold that into the scientific problem that I'm solving and incorporate that into my future state. Then the next step is, once you've actually developed that future state, let's transition to thinking about our technology. We want to bring the technology in and overlay that alphabet soup on top of the business process. What data will be captured in what system and why? Does it make sense to capture this in an ELN? Is the scientist already working in the LIMS system? Or are they already working in the ELN? Should we configure the solution? What solution should we identify to meet that particular need? You can then begin to use this to define your system requirements. By using this approach, you remove any implicit bias for vendor preferences just because they have some cool widget or some flashy dashboard. You can really define objective criteria for what solutions you need, how each plays within your solution architecture, and even develop an entire informatics roadmap for how multiple solutions will be phased in over time to kind of support your scientific business needs. Instead of having a collection of software that's underutilized, or sometimes I call shelfware, not being used in a fit-for-purpose manner, you'll actually have a blueprint to your future architecture, because every piece of software now has a map to your direct business process. Complete relevance and context for how that actually adds business value to that particular business process. This doesn't mean that there aren't other factors that may come into play when you make technology decisions. For example, you may choose to stretch a particular solution's capability beyond its original intent. But that will be done with eyes wide open, knowing the trade-offs that you'll be making and the reasons for those trade-offs, and how your scientific business and the business process will still be supported based upon that particular decision. If we look at kind of how some of the details on how do we get from a high-level business process to very specific scientific or system requirements, we have this example here, where we have a very simple process to maybe set up some samples to be run on an instrument. But as we actually drill down into that process, there's some system behaviors that we really need to have supported. Very simple questions such as, how do I select my samples to be included in my run? What instruments are available to me? I need to carefully place some QC samples with my run for quality purposes. I need to document consumables and other equipment that I'm using. And finally, for instrument I've chosen to use, the samples I chose and my QC samples being inserted, I need to generate a work list to send to that instrument. So you can see how your business process can be used to then begin to elucidate what are the system requirements. So for example, when I look at instruments and I need to make sure that I have an available list of instruments. Well, if I now think about that somewhere else within my business process, I probably have something that defines how I update and keep and maintain my list of available instruments and how they're qualified over time and how they maintain their certification and when their maintenance is up and due. So you'll see that even though I'm focused right here on running my samples this time through my instruments, somewhere else in my business process, I'm having to maintain that instrument's availability, that instrument qualification, and where that actually resides and how that then plays into whether that now instrument is available or not. You can see how these business processes translated into system requirements that now can be implemented, and actually gives me insight in the fact that I need that instrument integration to be developed. So for example, here where I have a run sheet that I might want to actually generate, I'm going to want to actually have an instrument integration so that the work list or the run sheet that is generated is specific for that instrument that I've chosen to run my samples on. So really, as we drive down and understand our business processes, they drive our system requirements and help us define those requirements and identify new opportunities for business and process improvement. In the past, that work list might have been someone selecting some samples, copying and pasting Excel, moving things around, where now my LIMS automate some of that for me. So we've really talked a lot about business process mapping and how it informs our technology decisions, and in a moment, how our informatics roadmap can be influenced by it. So where in the real world are we actually seeing clients come to us for this type of help? Is it really only for startups? You're sitting here and saying, I'm a big organization. Do I really need it? Is my research lab going to benefit from this? When would I want to take on an exercise like this? Well, there are many cases where you might want to do this. One obvious place is when you're looking to bring in new technology or software to support your laboratory. Instead of just going out and saying, listing system requirements, I need to be able to receive samples, I need to be able to generate a work list. Let's look at your business process and help that inform the requirements and features that you're going to be looking for in your next solution. We're also seeing, though, not just during new technology implementation for support of your laboratory, we're also seeing business process analysis and business process mapping happen with large organizations that have acquired system after system after system, maybe not intentionally, but through mergers and acquisitions. We recently learned of a client who has over 20 LIMS systems. Yes, 20. I didn't even think that was possible. But nonetheless, they're thinking about rationalizing those systems and seeing if they can streamline and harmonize their business process and remove redundant systems. So the goal there is to actually look at their business processes and harmonize their processes, get an understanding of what one group uses the system for, develop a common glossary and terminology between the laboratories and the scientific disciplines so that people are talking about the same thing And then they can begin to say, oh, that's what we call accessioning over here, what you call sample receipt. But let's go ahead and build out a business process and understand where our processes are the same, where they're different, and maybe optimize and harmonize onto a single process. We also see this in what I would consider maturing organizations. Maybe those smaller biotechs and startups that are beginning to become overwhelmed with managing their scientific informatics infrastructure on Excel or some other homegrown solutions that are just becoming unwieldy or difficult to support because people have just tacked on a new feature here, added this new feature there because someone needed it, but really doesn't really fit together as an entire business process. These organizations are often getting increasing regulatory pressures to implement more robust scientific software capabilities to support some of their advancing therapeutic programs. Excel and those homegrown solutions are just not going to cut it, both from a regulatory perspective and from a scalability perspective. These types of organizations greatly benefit from getting a better handle on their business process. What priorities they need now from the alphabet soup of LIMS, ELN, CDS, and all the other solutions? And what does their roadmap look like for the future as they continue to grow and mature as an organization and begin to need new additional technologies to support their growth? Which really leads me to kind of talk about how business process analysis is just not dealing with requirements for a specific solution or need, but really how business process analysis can really help you build out your entire informatics roadmap and architecture, defining what data you need to capture and the how, what systems need to be involved, and then kind of the intersection of the data and the systems to develop that data architecture and the solutions that support that data architecture. Using business process analysis will help you identify key differentiators to your business. Every LIMS or ELN or you name it solution can probably do the basics of allowing you to create an experiment, record your results in a notebook page, configure some level of approvals. But what you really need to consider is what really truly differentiates your scientific process or technology that you need to look for in a vendor or partner. And business process analysis, when done properly, will help you identify those key critical needs that differentiate and will support your business the best. They help you prioritize your capabilities and features based upon your current needs and your current maturity model, and then help you define what you're going to need as you go forward. Through business process mapping and overlaying of the technology, you'll have a better understanding of your ecosystem and how that architecture supports your business needs. Instead of having just a set of tools that are standing as individual silos, you have a better picture of how your data and technology architecture support your entire scientific business process. And most importantly, with the volume of data being generated today, your business process analysis can help you define better data governance and use of fair data principles. Data that's findable, accessible, interoperable, and reusable within your environment, so that you're actually maximizing the data you collect, and we're collecting lots of it now, as well as making sure that it resides in the right places and is available at the right time to the right people. With that, I want to thank you for your time today, and I'll turn it back over to Kevin.
Juan, thank you very much. Great presentation. Certainly very insightful for sure. A couple of things here real quick. I want to go ahead